So after learning how to graph um, radical functions, we are now moving into a new lesson, which is how to solve radical equations. And to solve a radical equation means, isolating the radical on one side of the equation and find the value of x. So a radical equation is any equation that contains a radicand. It could be, the radical is on the left-hand side, or maybe on the right-hand side, and last but not the least, there could be radicals on both left and right-hand sides of the equation. Now, after isolating the radical expression on one side, you're going to use this property to get the value of x, if x is the variable used. You have to square both sides of the equation. Remember, you don't just square the left. You have to do to the right whatever you did to the left. Now, also, you may extend this property to cube root equations. So if you have a cube root equation, to remove the index, you have to raise both sides of the equation to the power 3. So what we're going to do now is to look at some examples on how to apply this. So hopefully, by the end of this screencast, you will be able to solve an equation that contains square roots. So let's take a look at this. So for letter A, first you have to isolate this. So you have to move the 5 over. So radical x is equal to 13 take away 5 would be 8, right? And then after that, you have to square both sides. Why square? Because the index here is 2. Getting the square root means the index 2. And just like what I mentioned, whatever you do to the left, you have to do it to the right. So the index and the square cancel each other out, so you now have x is equal to 64. Now, in this lesson, it's very important to check your solutions because sometimes you get extraneous solutions. So you have to check for extraneous solutions. So how do you do that? You have to plug in, whatever value you get to the original equation. So let's say 64. What's the square root of 64? It's 8. So 8 plus 5 is 13. So that means x is equal to 64 is a solution. Let's try the other one. You can move either 3 or negative radical x to the right hand side. Now since this is negative, I prefer to move it to the right. So 3 is equal to radical x. And then after that, you square both sides again. So that's 9 is equal to x. So now let's see if this is extraneous or indeed a solution. 3 minus the square root of 9 is 3. So 3 minus 3 is 0. Okay, so what if the radicand is a binomial, which is in this one? Okay, let me move it over here so that happens. Okay, so first, remember you have to isolate the radical expression. So move the 6 over. 15 take away 6 is 9 equals 3w minus 9. So now you have to square both sides. So square 9. You also have to square this one. The index here is 2, so they cancel each other out. So 9 squared is 81 is equal to 3w take away 9. And then after that, it's just a linear equation that you for sure can solve. So move the 9 over. So 81 plus 9 will be 90. It's equal to 3w. So then w is equal to 30. Now again, check the solution. So if you plug in 30 for w, 3 times 30 is 90. Minus 9 is 81. So the whole thing becomes 81. What's the square root of 81? 9. So 6 plus 9 is equal to 15. Now here you see a radical on both sides. So are you going to put them together or are you going to leave them separate? Leave them separated. So if there are two radical expressions, put one on the left, put one on the right. Then you square both sides. So now you see why we have to keep them separated, right? So if you square both sides, the radicals cancel out. And now you have n is equal to 5n take away 1. So if you collect like terms together, move the 1 over here. 5n minus n, so you have 4n. So what is n equal to? It's 1 over 4. So let's see, let's plug it in. What is the square root of 1/4? Well, that's 1/2, right? So the square root of 1/4 is 1/2. Now let's substitute 1 over 4 here. So 5 times 1 over 4 take away 1. So this will be 5/4 minus 1. But 5/4 is actually the same as 1 and 1/4. So if you take away 1, you will have 1/4 remaining. So what is the square root of 1/4? It will also become 1/2. So that means n equals 1 over 4 is a solution. Now, does it also work for cube roots? Well, let's see. Okay, so how do I remove the index 3? So what we're going to do is raise both sides to the power 3. So you cube both sides of the equation. That will cancel the index and the exponent. So 5x take away 2 is equal to 1728. So double check that. So now we move the 2 over. So 5x is equal to 1730. And when you divide both sides by 5, then you will get 346. Okay, so let's double check. Plug in 346 over there. It's 5 times x, so multiply it by 5. It says minus 2, so take away 2. And then now you get the cube root, so you get the cube root of that, and you get 12. So you know that your answer is right. Okay, let's do this. So move the 4 over, becomes plus 4. So cube root of y is equal to 5. And then you cube both sides, so cancel. Y is equal to 125. So let's see. Cube root of 125 is 5, because 5 times 5 is 75, times 5 is 125. So this is 5. 5 take away 4 is 1. So now let's try this. We cannot combine the variables. We cannot collect like terms because this is a radical expression. This is not. So, have we separated the radical expression? Yes. Okay, we can't move the 6 because it's part of the radical. So that means we're ready to square both sides. Okay, so if you square this, that's x squared. If you square this one, they will cancel each other out and you have x6. Does that look familiar? So when you see x squared, automatically what do? You move everything together on one side of the equation and make it equal to 0. Okay, can we move this one? Yeah. Alright, so how do we solve this? Okay, by this time, if you don't remember the other shortcuts, you should be able to do at least the quadratic formula, right? Okay, but I think this one is factorable. So let's find two numbers and multiply to -6. That's 3 and 2 which one should be negative? We want the sum or difference to be negative, so we have to put a negative on the 3, correct? So the factored version is x minus 3, x plus 2 equal to 0. So by 0 product property, x is equal to 3 and x is equal to negative 2. Excuse me. So now let's check for extraneous solution. Let's try 3 first. If this is 3, let's try this. 3 plus 6 is 9. What's the square root of 9? 3. Okay, so 3 works. What about negative 2? Negative 2 plus 6 is 4. What's the square root of 4? Positive 2, right? And this one is, you plug that in, negative 2. So that means only x plus 3 is a solution, and this one is extraneous. Why is it extraneous again? Because when you substitute it here, square root of negative 2 plus 6, that's square root of 4, and the square root of 4 is positive 2. So positive 2 is not equal to negative 2. Next. So you have to move the 13 over. Take away 13 here, so that's negative 10. Okay. Well, at that point, you can kind of say, oh, if I get the square root of something, it would be negative. You know, you can decide whether you're going to proceed or just write your conclusion already. Anyway, so going back, if you square both sides, you get 5n, because they cancel, is equal to 100. So if you divide by 5, n is equal to 20. Let's see. 5 times 20 is 100. So square root of 100 is 10. 10 plus 13, definitely that's not equal to 3. So this one is not a solution. It's extraneous. There you go, because it makes the equation